Okay friends, let's have a look at the practical where we will make a half-wave rectifier using a transformer, a diode, a PN junction diode, a simple load resistor. Now, before we start our practical today, let's have a look at the transformer. Now, as we can see, the transformer is basically having two sides. This is the primary side and this is the secondary side. Now, if we turn the transformer, we can see that it's written 230 and input. Now there is a power cord, so live wire is connected to this terminal and a neutral wire is connected to this terminal. Now let's look at the other side. Now this transformer is a bit different from what we have studied in the theory part of half-wave rectifier. In the half-wave rectifier, what we have studied is a bridge type transformer. That means it will only have a zero terminal, that is usually called the common terminal, and a terminal usually designated with a voltage. Here it's written 12. Now the transformer that we are using today is a center type transformer. That means it is having a voltage rating of 12, 0, 12. What we can do is we can use these two terminals, that is the common terminal and any one of the terminals for our experiment. Now we have to be very careful while considering the primary side. After connecting the power cord, it's better we keep this away from our body, otherwise there can be some fatal shocks. To avoid that, we usually go for insulation, but we'll assume that we are practicing enough safety so that we do not get a shock. Now, let us take a wishboard. Now, what is a wishboard? Wishboard is basically used for designing different type of circuits. Now, you can build this on a board also, but on a board you need to have solders. That is, you need to have a solder iron, you need to have a solder, and you need to have solder flux so that you can make the connections on the board. Now, to have different type of circuits on the same board, we use the breadboards or the wishboards. Now let us first try and understand how this breadboard works. You can see there are two rows over here. This is the top one and this is the bottom one. Now usually the upper row and the lower row gets terminated at the middle of the wishboard. Now if we connect a wire here and a wire here, both the wires are then connected together, but this row is different from this. That means if you have a wire connected on the top of the top row and a wire on the bottom row, those two wires will not be connected, they are separate. Similarly, the same thing repeats at the bottom. Again, it gets terminated at the middle. Now if we have to continue this row till here, we will have to connect a jumper wire which will enable the connection between this row and this. Now in this particular section there is an isolation between the upper half and the lower half. Now, these are the connections which are in the column format. That means if you have a connection here and a wire here, then you can say that these two wires are connected. But the very next column is not the same as this. This column is isolated from this column. Hence, if we connect a wire here and a wire here, those two wires will never be connected. The same thing happens at the bottom of it. So now let's start our experiment. What we'll do is we will take the common terminal and connect it here. Now you can use any one of the terminal, that is either you use this or use this, doesn't matter. So we will take one wire and connect it here. Now the 0 is here and the 12 AC12 is here. Now what we will do is we will take the PN junction diode. The PN junction diode, what we can see is having a silver band on this side. Now the silver band means this particular terminal is N type and this particular terminal is P type. So to construct a half wave rectifier, what we need to do is we need to have a transformer. This is the primary part, which is connected to AC 220. This is the neutral. This is the live. We have the secondary. We have the common terminal, or in this case it is also called the CT terminal, that is the center tap terminal. We will be using any one of this. Since it is a 12-0-12 transformer, we will write like this: 12, 0 and 12. Now we will use this terminal and this terminal, which is similar to having a 0, that is the common terminal connected here, and the AC voltage terminal connected here. Now we'll use a PN junction diode. This P side is connected to this terminal. Let's label this as X, let's label this as Y, and let's label this as Z. Now the inside of the PN junction diode is connected to a load resistor RL, and it is returned back to the common terminal. So this is the basic circuit that we are going to design today. Now we have already connected the 12-volt terminal to this section and the common terminal to this section. Now we will take the PN junction diode and connect the P-type with this. To connect the P-type, we will simply prime the terminals, connect it here and connect it to one of the sides. Okay. Now, since this wire was connected into this particular section, the diode's P-type is also connected to this column. The N-type is presently left open. We'll have to connect a load resistor from here to the common terminal. We have few load resistors with us. Now we have a 1 kilo ohm resistor, we have a 10 kilo ohm resistor, we have a 560 ohms resistor, we have a 680 ohms resistor, we have 330 ohms resistor, and we have a 820 ohms resistor. Now we have different values of resistors. Why are we having different values of resistors? What we will do is we will first connect one of the load resistor, that is obviously with a higher value. So when we connect a load resistor with a higher value, we'll expect a current which is of a lower order. Now, as soon as we decrease the value of RL, what happens is the current in the circuit will increase. What we will do is we will try to measure the output load voltage, which will be available here. We will call that VL across the RL, and we will try to measure the current which is flowing through this terminal, which we will call IL, and we will plot IL versus VL. Now that will provide us an idea about the load regulation. Okay, now let us first choose the RL to be 10 kilo ohms. Now the 10 kilo ohm resistance is connected between the N-type of the diode and the common terminal of the transformer. Now we all know that the output voltage that we will be getting across the resistor is the average voltage, which is VDC, and which is usually given by Vm by pi. Now what is Vm? Vm is the peak voltage. Now the voltage that is appearing on the secondary side is nothing but the RMS voltage. We also know the relation between the peak voltage and the RMS voltage is Vrms into root. That is, the peak voltage is equal to the root mean square value of the voltage into root 2. Now we know the value of the RMS voltage on the secondary side, and we know the value of root 2. So what we will get is which comes out to be 16.968 volts. Now, we also know that VDC is equal to Vn by I. Hence, substituting the values, what we get is 5.40 volts. Now let's see whether we can come close to this voltage. Now, for measuring purpose, for measuring the voltage, what we are going to do is we are going to use a voltmeter. Now, here we are using a digital multimeter. Now, what is a multimeter? As we can see that it's having a dial. Now, one side of the dial shows V with a straight mark. This means that this section is meant for measuring DC voltage. Now, the range is from 200 millivolts to 600 volts DC. Now, if we look onto this side, it shows V with a ripple mark. Now, this ripple mark denotes that this scale is for measuring AC voltage. Now, AC voltage range is from 200 to 600. Now, if we look here, we can see A with a straight mark. Now, A with a straight mark means we are going to measure DC current, and its range starts from 200 micro to 200 milliamperes. Okay. Now, here's 10 ampere also, but for measuring 10 amps of current, you need to change the hot probe from this section to this section, and this is the cold probe or the common terminal. It is usually written on the meter here, and this particular terminal is connected here, and it is for measuring volt, ohms, and ampere. Now, if we look into this side of the dial, what we can see is it's written 2 meg to M, 200K, 20K, 2K, 200. This means in this particular range, it is between 0 to 20 ohms. So any resistance value which is between this can be measured in this range, and similarly other ranges. Now, there are two more options. Now, if we have a transistor, transistors are basically of two types. We have PNP, we have NPN. Now, to measure the HFE, the gain of the transistor, we can use these terminals and the dial for measuring the HFE. That will provide us the static HFE, that is the beta of the transistor. Now, let's now connect this voltmeter. Change the dial to 20. Take the ground terminal, which is the black wire, connect it to the common terminal of the transformer. We always measure voltage with respect to the common terminal. Connect the hot probe to the N type of the transformer, N type of the diode and then switch on the transformer. Now let's switch on the transformer. Now if we switch on the transformer, what we can see is the voltage reading is around 6.36, but we were expecting a voltage of 5.40. The voltage that we are getting here is 6.38. This may happen if the voltage at the secondary side is greater than what it is written. Let's now try to check the AC on the secondary side. As we can see, it's showing 14.2. So if the voltage on the secondary side is 14.2, then definitely the output voltage will increase. Now let's redo the calculation. Now if we redo the calculation, now let's do the calculation again. The AC, the peak voltage is Vrms into root 2. Now Vrms is 14.3 into root 2, which turns out to be 20.22 volts. Now if we calculate the average DC, which is Vm by pi, now it's 20.22 divided by 3.14, and it turns out to be 6.43, which is exactly what we are getting. Thank you for watching half-wave rectifiers. This is only the preliminary part. We will again come and see how the filters are applied, how we can see the waveforms on the cathode ray oscilloscope. Thank you for watching. Bye bye.